Hi friend! In today's video I'm going to share with you how to add a structured VFD control to your own TIA portal applications. And if you like structured programming, if you'd like to create better PLC applications in TIA portal, then I have a special gift for you today. I have created a downloadable free guide for you in which I share 5 steps to instantly improve the structure of your PLC applications in TIA portal. If you'd like to go and download the guide, then go and check the description below the video and click on the link. Alright, so nowadays frequency controls are used in a wide range of industry applications, and one of the major strengths of using VFDs or variable frequency controls is that you can precisely control the speed of devices like pumps, valves or conveyor belts. Siemens TIA portal offers a wide range of VFDs that you can integrate into your PLC applications. And today I'm going to share with you how to add a Siemens G120C frequency converter to your own PLC application. This is a very versatile, low voltage frequency converter from Siemens. I've seen it used on many production lines out there while I'm doing my commissionings. It's a very popular frequency converter. And in our example here, I'm going to use those frequency converters to control the speed of 2 process pumps. All right, that's it for this short introduction. Let's jump right into it. So we are going to add a VFD to our PLC application using the following 4 steps. First, we're going to add a VFD from the hardware configuration to the Profinet network. Then afterwards, we're going to set up which data communication we are going to have between the VFD and the PLC. Third step, we're going to create structured inputs and outputs using UDTs, user-defined data types. And last, finally, we're going to build a standardized function block which will encapsulate all the logic necessary to control the VFD. I believe these steps are pretty straightforward and pretty easy to follow. So if you follow them precisely, you will be up and running with VFD controls in your own applications in no time. All right, so let's start with the first step. We're going to add a VFD from the hardware configuration, or the device configuration as it's called in TIA portal, to our Profinet network. So right here we are in a sample application which is part of my premium bundle TIA portal All Basics pack. And in this refill application we will use the VFD to precisely control the speed of 2 process pumps for pumping water from a supply tank to 2 process tanks. To add VFDs to the Profinet network, we first need to open the device configuration, which is right here. Now we go to the network view. And here you can see a nice overview of the different devices that are connected to our Profinet network. At the moment we have a PLC, we have an HMI, and we have 3 communication nodes for inputs and outputs. So here we are going to add the 2 frequency converters for the pumps. The first thing we need to do is we go to the hardware catalog here on the right side, and we search for the frequency converter that we want to add. As I explained to you in the beginning of this video, we are going to add a G120C frequency converter, which is a popular frequency converter. I've seen it used on many different production lines. So here I've typed it into the catalog, I've pressed enter, and our first search result takes us to the Dynamics G120C folder, here under the Dynamics Drive main folder. Now if we open up this folder, you can see that there's different networks we can choose from. We are going to use a Profinet network, which is PN, so we open this folder right here. Now this opens up an extensive list of different types of G120C drives, and they're neatly organized by power rating, for example 0.55 kilowatts, 1.1 kilowatt, etc. And the type of filter. FA means filtered, which means an EMC filter has been built in, and UF means unfiltered, which means an EMC filter has not been built in. Now for this example, I'm going to select a 1.5 kilowatt drive with an EMC filter. So I select that right here. And I drag it over to the network view. Here we go. And now it's on our network view. The drive is not assigned yet, so we click right here and we assign it to our PLC device. There we go. Let me just drag that down here to have a nice overview. So let's give this one a name as well. So this will be the frequency converter for pump refill process 1. So I type in pump refill 1. So that takes care of the first VFD. So now we need a second one as well for the second pump. So we do exactly the same. We drag it over. We put it into place. We assign it to the PLC device. And we rename it to pump refill 2. There we go. So let's put this one aside a bit so we have a nice overview. So now we have our two frequency drives connected to the Profinet network. The only thing left to do here before we go to the next step is assigning an IP address to each drive. To assign an IP address, we first click on the drive itself. Here it's important that you click on the drive and not on the gray area next to it. And now we go to Ethernet addresses. And now we select an Ethernet address that is in the same range as the Profinet network. So for this device, for example, I will choose 100 for the last number. And I have a habit to do the same to the device number. So I'll use device number 100 for this one. And now let's do the same for our second VFD. This one will be 101 with device number 101. Okay, that takes care of the first step. We have added the VFD to the Profinet network. The main idea behind having a frequency drive on a network like Profinet is to be able to control the VFD directly via software. We don't want the hassle of time-consuming wiring or I/O testing. We would like everything to be set up directly in the P application, and the only thing that we need to do as a programmer in our application is programming the logic for the commands to the VFD and interpreting the status signals coming from the VFD. But how do we know which data is being transferred between VFD and PLC? And how do we set this up? How do we configure this? Well, TIA Portal uses telegrams to define which data is being communicated between PLC and VFD. And we configure our telegrams by going first to the general configuration and then selecting the telegram configuration right here. Here you can see under the telegram tab which types of telegrams you can select. There's a standard telegram 1, standard telegram 20, etc. There's even a free telegram in the end. We are going to select here standard telegram 1, which is 2 words of length in the send direction and 2 words in the receive direction. And it contains all the necessary communication data that we need for a simple VFD control of a pump. So we leave it like that. One last thing I would like to set up here before talking more into depth about this telegram is to set up the input and the output area for this telegram. So this we do by going to the end right here under partner data area. And for the inputs, I'm going to select input area 500. So that basically means that our inputs start at input byte 500 and ends at input byte 503, which means we will have 2 words or 4 bytes of input data. And for the outputs, I'm selecting output 500 for the area. So that means that we're going to have 500 to 503 is again 4 bytes, 2 words of output data. In the same way, we go to the second pump. We check the telegram, standard telegram 1, so that's correct. And we set up the input and the output area. And here it's already set up correct to input 510 and output 510. I already did this before the video. So first pump, input output 500, second pump, input output area 510. All right, so now let's have a look which data is being communicated with standard telegram 1. We do this by clicking on the green arrow here under the link tab. And this takes us to the parameters for this VFD, and more precise, it takes us to the communication area for the receive and the transmit direction. So let's open this up a little bit and make it more clear. Okay, so here we are in the transmit direction, as you can see at the top. And the first thing you'll notice is that you can again select your telegram. So this is still displaying standard telegram 1 because this is what we just configured before in the device configuration. And you can choose any of the other telegrams right here as well. Below this is the area for the Profinet configuration. I am not going to go into detail here because it's a whole different subject that only makes sense if you're using STO or any other safety feature on your VFD, and it's not the main topic of this video, so we'll leave that for now. Maybe that's a topic for another video. What's more interesting for us is the Profi drive configuration underneath. The first thing you can see here is that there are two words configured for the transmit direction of standard telegram 1. The first word is the ZSW1 word, which is a German abbreviation for status word. And the second word is the actual speed of the drive, which here is displayed with the word NIST_A, which again is a German abbreviation. To be honest, I'm not really sure why Siemens decides to keep these German words in the English version of TIA Portal, but hey, that's the way it is right now. I hope they maybe transition to only using English words in an English version of TIA Portal in the future, but we'll see. So we have a status word, ZSW1, and we have an actual speed of the drive, NIST_A. Now, the status word is a collection of flags, collection of bits that comes from the drive. And if we would like to see which bits are in this word, we simply click on the word itself, and the pop-up screen shows us the 16 flags which are part of this status word. So you have ready for switching on, ready, operation enabled, fault present, etc. These are all status signals coming from the frequency drive to the PLC. All right. Now if we go and have a look at the receive direction, the receive direction is which data the frequency converter receives from the PLC. So these are actually the commands from the PLC. And we can see what those are by clicking right here. Again, standard telegram 1 is configured. The Profi safe we're not going to go into right now. And here on the Profi drive, you can see that two words are configured for the standard telegram 1. Our first word is called STW1, which is a German abbreviation for control word. And the second word right here is called NSOL_A, which means the speed set point for the drive. So what we will send from the PLC to the VFD are in the first word the control flags, and in the second word, the set point speed for the drive. Make sense? All right, just like before, if we want to know which flags are part of the control word, we click on the control word right here. And here you get a nice overview in the pop-up screen of all 16 flags, all 16 control bits, part of that control word. Some important flags, some important control bits to mention here is control bit 0, which is the on-off control bit. This one is used to actually start your drive, so to actually make your drive start moving. Control bit 7, the first acknowledged faults, is used to reset any faults you would have on the drive. And another interesting control bit would be bit number 11, the set point inversion. So if, for example, your drive is running in the wrong direction, you can change this bit from false to true or true to false to change the direction of the drive. All right, just one thing I would like to show you before we go on to the next step where we're going to build structured inputs and outputs for the drive is that each telegram contains their own configuration of words. If we go back to the top here and we select a different telegram than standard telegram 1, for example, Siemens telegram 354, then you can see when we scroll down, when we go down right here, that we have 6 control words now instead of 2. We still have the same 2 that we had before, the STW1, the control word 1, and the set point speed NSOL_A. But on top of that, we have 4 configurable user words sent from the PLC to the VFD. So each telegram is different. Each telegram has a different setup of which words it's communicating in each direction, receive or transmit. But as I mentioned before, we are going to go with standard telegram 1 here, because it has the necessary communication for a simple VFD control. One final remark here, the telegram that you select for the receive and the transmit direction is always the same. So you cannot, for example, select standard telegram 1 for the receive direction and Siemens telegram 354 for the transmit direction. So the telegram for receive and transmit direction is the same. So now that you know about telegrams and how to set up which data to communicate between your VFD and your PLC, let's go and have a look at how we can pour all that data into an awesome data structure that we can then use in our PLC application. By now you probably know from watching some of my other YouTube videos or maybe some of my courses that you followed that I am always very passionate about creating structured PLC applications. In my opinion, striving to become a structured and organized PLC programmer is probably the best education that you can give to yourself, and it can open up a lot of new and exciting career opportunities as well. So this brings us to the next step, the third step in this VFD implementation tutorial. We are going to create structured inputs and outputs for our drives. I mean, if we look back, so far we have added a VFD to our Profinet network in the device configuration, and we have specified which data we would like to communicate between our PLC and our VFD using a telegram. Now we are going to structure that telegram data, we are going to map it into user-defined data types, and afterwards we will declare inputs and outputs for each drive using those UDTs. So if we have a quick look back here at the telegram configuration of our receive direction, which is open still right here, we can see that we have two words set up, which is one control word with 16 control flags, 16 control bits, and a set point speed for sending the desired set point from the PLC to the VFD. So it's these two words that we are going to map to a user-defined data type. And afterwards, we are going to map the words from the transmit direction, which is a status word and a word containing the actual speed, to a second user-defined data type. Okay, so let's get started. To add a new data type to our PLC application, we go to the PLC data types group right here. And you can see that we already added some different groups here, one for machine, one for equipment, and we added a library group. Since our VFD control is going to be a universal control block that we can use for different modules in our application, we are going to add these new data types under the library. So we open up the library right here. I've already created a folder for Siemens UDTs and for user UDTs. And here you see we already have a UDT for PID control. This is a feature which is as well available in the premium edition of my TIA Portal All Basics pack, which is a training bundle. And again, if you're interested in this training bundle, go and check the link in the description below the video. So we have a PID control and we would like to add two UDTs, one status and one command for our VFD control. First off, I'm going to create two new groups just to make this a little bit more organized. One group called PID and another group called VFD. And I will move this PID control nicely under the PID group. And here for the VFD group, I'm going to create two new UDTs, one for the command data, which is the receive direction from the VFD point of view, and one for the status data, which is the transmit direction from the VFD point of view. So to add a new UDT, I right-click and I press Add New Data Type. So let's start with the command. So I'll rename this one to UDT VFD command. And the data that I'm going to be added is the data right here under the parameters for the receive direction. So we're going to have a control word with these flags, with these control bits. And we're going to have a second word for the set point speed. So the first word will be a control word, which I will define as a structure of 16 bits. And the second word will be the set point speed. Now for the control word, we have 16 bits, so I will quickly add them right here, and then afterwards we can have a look at the overview. And there we go. So we got a first word, which is a control word with 16 control flags. And we have a second word with the set point speed. So what we did right here is pretty simple. We just mirrored the data from standard telegram 1, the receive direction, to a user-defined data type in the PLC called UDT VFD command. Now we are going to do exactly the same for the status words. So let's have a look again. This is the transmit direction from the VFD point of view, where we said we have two words of status, which is the status word 1 right here with 16 status flags, status bits. And we have a second status word for the actual speed. So we create a new data type. We call it UDT VFD status. And we mirror the communication from the telegram. And that's it for the status words. So we have two status words. The first one are 16 status bits, and the second one is the actual speed. And again, the only thing we did is we mirrored the telegram communication in the transmit direction from the VFD point of view. So what we have right now are two brand new user-defined data types for the VFD control, one for the command direction from PLC to VFD, and one for the status direction from VFD to PLC. The only thing left to do now is to create structured inputs and outputs for our VFDs using these user-defined data types. So creation of inputs and outputs is done under the PLC tags group right here. And since we are creating a frequency control for our process pumps, which are part of the equipment modules, it means that we are going to create our inputs and outputs under the equipment group. And what you can see right here under the equipment group is that I've already created tag tables for inputs equipment and outputs equipment. These contain the inputs and the outputs of the other examples, the other features that I'm using here in this training bundle. Right now we're going to add VFD inputs and outputs to this equipment group. And what I like to do for VFDs is create a separate tag table to make it clear that these are inputs and outputs for VFDs. So I right-click right here, and I select New Tag Table, which I will call VFD Equipment. Now we open the tag table, and I will first start by adding the inputs and outputs of the first process pump. So for the inputs of the refill pump of process 1, I will use the data type UDT VFD status. The address for this input is the same input range that we declared in the device configuration. So if we quickly head back and we check out the telegram configuration for the first pump, then you can see that we have declared the input and the output area as input area 500 and output area 500. So we entered the same range right here under address. So input area 500, and for the VFD outputs of refill pump process 1, we select the UDT VFD command as the data type and the output address 500. Okay, so now we configured the input area and the output area for the VFD of our first pump. For our second pump, it's really easy. We copy paste this. We change the names to process 2. That's what the P stands for, process. And we change the input and the output address And that's really all you need to do to set up structured inputs and outputs for your variable frequency drives. You start by creating user-defined data types, UDTs, that mirror the telegram communication that you set up, and afterwards you add inputs and outputs using those data types. It's actually quite simple. Alright, so far we have added VFDs to our device configuration to our Profinet network. We have defined which data we would like to communicate between the VFD and the PLC using our telegram configuration. And now in this step, we have created structured inputs and outputs for the VFDs using user-defined data types. We've covered a lot already, but we're not totally there yet. We just have one final step left, but this might be the most interesting step of them all. In this final step, I'm going to share with you how to build a standardized function block for a VFD control or any type of control for that matter, and how to integrate this block into your PLC application. So as I've mentioned before, this VFD control block is a multi-use control block that can be called in different parts of your application, in different modules. So for that reason, I have decided to classify the control block, the VFD control block, in the library folder. So if we have a look here under my library folder and under the user folder, you can see that I've created a FB VFD control, which is a standardized control block encapsulating all logic necessary for controlling the VFD. So this block is used to control the pumps of the refill application, the process pumps of the refill application. The refill application is part of the equipment group. So if we open this group and we look at equipment modules, which is the main function block that calls all the function blocks for the equipment modules, you can see that we have 4 networks here under the equipment modules, one for the configuration, one for the supply module, that's another module in this sample application, and 2 modules for refill process 1 and refill process 2. So the VFD control for our pumps are part of this refill process 1 and refill process 2, one pump for each process. Now if we check the logic in this network, you can see that we're calling a function block FB EM refill, EM standing for equipment module. And if we open this function block, then we can find our VFD control block right here under network 8. So the FB VFD control is a standardized control block for controlling a VFD with standard telegram 1, and it is called here using a multi-instance in the FB EM refill. So I'd like to point out a couple of interesting inputs and outputs on this FB VFD control block. If we have a look at the inputs, which are situated right here on the left side of the function block, you can see that we have a set point speed input, a real, and this is typically a variable that comes directly from the HMI. Most likely it would be an input field that the operator uses for entering a pump speed between 0 and 100%. As we've seen in the previous step, the VFD will receive this set point speed through control word 2. Another interesting input here on the block is the run input, and this is the actual signal that will start moving the drive. Now if we have a look on the right side of the function block, the outputs, you can see that we have status information for drive ready, drive running, drive faulted, set point reached, and the actual speed. So these first status outputs, drive ready, drive running, drive faulted, and set point reached, are coming from the VFD through status word 1. The actual speed status, you might remember that that comes from status word 2. And one last thing here before we actually have a look inside the block itself is the way that our input and output structures are connected to the block. Well, that is done right here through the in-out parameters of the block. The VFD status is the 2 status words that's being sent from the VFD to the PLC, and the VFD command are the 2 command words that we send from the PLC to the VFD. And as you might remember, these are exactly the inputs and the outputs that we defined in the previous step. Now let's go and dive inside the control block itself and see how logic is organized inside. Okay, so let's start by minimizing the networks so we get an overview. And as you can see here, we have 3 main parts in our logic. The first part, which is network 1, contains logic to validate the speed set point. It will check if the speed set point is within acceptable limits. I mean, this is my recommendation here. If you're building a standardized block for any kind of control, you should always start by validating the parameters going into the block. These will typically be parameters from input fields on the HMI, and by making sure that these parameters are within limits in the beginning of your control block, you will avoid many troubleshooting hours later on when you're commissioning the machine or when the machine is running production. The second block of logic, which are networks 2 to network 7, contain all the logic necessary to command the VFD. So if we look here, for example, on network 4, we can see that here we have a fault logic, a reset fault logic for acknowledging faults inside the VFD. So if the input for fault reset goes high, we will send a pulse of 2 seconds to the command bit number 7 of the VFD command word. If we go, for example, to network 6, where the run signal is generated, we can see that if the input for run is high, the status word bit 3 indicates there's no fault present, and status word bit 0 indicates that the VFD is ready for switching on. Then we energize bit 0 of the control word. And finally, let's have a quick look at network number 7. This is the speed set point. And here you can see that our set point speed is being converted from a 0 to 100% input field on the HMI to a analog value 0 to 16,383, which is being sent to the VFD. Okay, so that's it for the second block of logic related to the VFD command. And now the third block of logic is related to the status signals from the VFD to the PLC, right here in networks 8 and 9. So if we open network 8 here, for example, you can see that we are mapping the different status bits of our status word 1 to the outputs of the control block. And finally, in network 9, we are converting the actual speed, which comes through status word 2 from the VFD to the PLC. We are converting this from a 0 to 16,383 analog value to a 0 to 100% output on our control block. So if you would like to work with the logic in this sample application with the VFD control, the PID control, and dozens of other advanced features for your PLC and HMI applications, please go and check the description below the video. As I've mentioned before, this sample application is part of the premium edition of my TIA Portal All Basics Pack training bundle. You will get this full TIA Portal sample project, including a PLC and an HMI application, and it comes with a huge how-to guide, including step-by-step instructions on how to integrate each one of these advanced features into your own PLC and HMI applications. So go check that out. Whoa, that was a lot of information to digest, right? Well, now that we've reached the end of this tutorial, I hope that you feel more confident implementing a Siemens variable frequency drive into your own PLC applications. And I hope that you got a clearer understanding of how to add a VFD to your device configuration, how to configure which data to communicate between PLC and VFD using telegrams, how to properly structure VFD inputs and outputs, and how to build a standardized control block for your VFD that you can call in different parts, different modules of your application. And as I mentioned in the beginning of the video, if you're really committed to creating structured PLC applications in TIA Portal, then go and download my free guide by clicking the link in the description below this video. I hope you enjoyed this tutorial, and I'll see you on the next video.